Hello student, I'm Abhijeet and let's start learning the IBDP chemistry reactivity 2, and today I'm going to explain the reactivity 2.21. Let's start. So this is reactivity 2.1 where we are going to study its how much, how fast and how far, right? So in this chapter basically we have total 5 points. So we have chemical equations, right? Then this stoichiometry is important. Second, we are going to study the mole ratio, okay, and then the volume of gases, volume of the reactant, then the concentration of reactants. Then we have to study what is the limiting reactant, right? Then percentage will and this is new concept called atom economy, right? The mole part you have already done in your 10, so atom economy is completely new concept. So without wasting time, let's start the end of your questions. Yeah, so first MCQ. So just look at that, the exam style questions, multiple choice questions. Now look at here. Whenever you see these equations, the first task is observing these chemical equations very carefully. Okay, so these equations are very important, and after observing this, all are the coefficients you need to see carefully. Okay, these coefficients play very significant role when stoichiometry we are learning, right? Read the question. How many grams of SO2? Where is the SO2? Yes, SO2 is our product. Correct. Will be produced from 0.25 mole of FeS2. Okay, now forget 0.25 mole. Come to the equation. FeS2 is a 4 mole, SO2 is a 8 mole. So it is approximately double. If this is 1, this is 2. If this is 4, this is 8, right? We have to focus on FeS2 and SO2. Forget the remaining equation. Now they have given how many grams of SO2 is produced from 0.25 mole. Now from the equation we can see this is 4 mole and this is 8 mole, right? 0.25 mole will become double, right? So 0.25, the double will be 0.5 or 0.50, correct? So this is the first step. Most of the students don't understand this concept. So this is the first step. From this stoichiometry, we converted the 0.25 mole to the 0.5 mole. How? This is 4, this is 8. If this is 0.25, this will be 0.5. Of what? SO2. Now, next step. Number of moles is equal to mass upon molar mass. Correct? Now, number of moles from the stoichiometry I got 0.50. Mass I wanted to find, that will be X. Molar mass of SO2 you have to find, the sulfur. Atomic number is 16, mass number is 32. Oxygen a single oxygen has atomic mass 16. Since two oxygens are there, so this is 16, 16. So this is 32, and this again 32. So total it will become 64. Right? If it is 64, so molar mass of the SO2 will be 64, correct? So we want this X, simple cross multiplication, 0.50 into 64, we can use the calculator, right? We can use the calculator, 0.50 into, sorry, 50 into, because 100, 0.58, 0.50 into 64. The answer we get 32, right? And we can see their equation. You can see here option 32. We have the option 32. Where is the option? Yeah, option number B. So we can see here option B is the correct answer. Now we can move to the forward. Second equation, third problem. Okay. In which mixture sulfuric acid is limiting reactant. Now always remember, whenever such a type of equations are given, the first task is to writing the balance equation. Okay, forget the mole and all. First task you do the writing the balance equation. Go to the on the back side of your paper or rough page, and you can start writing that H2SO4 reacts with KOH. Second, H2SO4 reacts with calcium hydroxide, right? Now here KOH, now we have to balance this, so I'll get the product K2SO4 plus H2O. Second, I will get the product CaSO4 plus H2O, right? This is my equation. Now you need to balance the second task. You need to balance, so this is H2SO4, this is K2, I have written here, so I will write here 2. So this is K2, 2, SO4 is 1, H2 is total here 2, here 2, total 4, so here only 2, so I will write here 2. Similarly here also will become 2, calcium 1, hydrogen 2, hydrogen total this 2 and 2, 4, yes, sulfate is 1 sum. Now from this we can understand the ratio of H2SO4 to KOH is what? To 2. Here ratio is 1 as to 1. Means what? If H2SO4 is 1, this should be double. So in first case we can see you have 0.1 mole and this is 0.2, so this is double. So this equation is balanced, no limiting, no excess. Second equation we can see H2SO4 is 0.2 and KOH is 0.1. Actually it should be double of H2SO4, so it should be 0.4, right? But this KOH is less and this is excess. So in this case I can say that KOH is a limiting reactant and H2SO4 is excess. So B option is gone. What we want H2SO4 is a limiting, right? Sulfuric acid we want limiting. Now third option, C options we can go 0.1 mole of H2SO4 and now this over. Now look at here. Now we are going to the second equation where we need the ratio is what? 1 as to 1. So here 1 mole of H2SO4, we need 1 mole of calcium hydroxide. Since this is 2 mole of calcium hydroxide, the calcium hydroxide is in excess. If calcium hydroxide is in excess, definitely this is what your limiting reagent, right? We want zero point 0.1, this should be 0.1, but this is excess. Calcium hydroxide, this is excess. If this is excess, H2SO4 will be limiting. So we got the answer C. But let's check the D also. We have 0.2 mole of H2SO4 and zero point 0.1 mole of calcium hydroxide. Since 0.2 mole of H2SO4 we have, we should have 0.2 mole of calcium hydroxide. There is a less. So here calcium hydroxide is limiting and here H2SO4 is excess. So in D, H2SO4 is excess, but they have asked which is limiting. So only C option, our option is C. So H2SO4 is limiting. Now go to the fourth question. What is the percentage yield? Now these questions are very famous and every year in the exam we have these questions. Now let's remember the percentage yield. If you know the formula, you can easily solve these questions. Now these questions they have given at STP since everything is in gas. So your formula, you need to remember the formula. That our formula is what? Number of moles is equal to volume upon molar volume, and this molar volume is always fixed, which is 24 dm cube, okay, or which is 24,000 centimeter cube, okay. This is the fixed since they have given dm cube. Now if you look at the equation, they have given what is the percentage yield when 18 dm cube of ethane is produced. So what is produced? This is produced 18 dm cube, right? 18 dm cube is produced from 20 dm cube of ethene. Now if you have done the organic chemistry, looking at the formula, you can understand this is your ethene, which is a 20 dm cube, and from 20 dm cube 18 dm cube is produced. So definitely we have extra reactant and we have less product. Now looking at the stoichiometry, looking at the original equation, the mole ratio was 1 as to 1, means a 21 as to 1. If 1 mole of ethene reacts, you should get 1 mole of ethane, right? 1 mole of ethane, but actually we are getting 18. So simply we can do a math. Okay, so 18 upon, so I will just do your simple maths. I'll just write here, yeah, 18 upon 24. So 18 upon 24 will give me the will give will give the actual yield, right? So 18 upon 24, if you do 18 upon 24, so I will get 0.75. So 0.75, 0.75 is what my actual. I'm getting 18, okay, is producing from 20 dm cube. Now 20 dm cube we have used. So from 20 dm cube, what is expected? So 20 upon 24, if you do this simple maths, 20 upon 24, 20 upon 24, simple maths, I'm getting 0.83, right? I'm getting 0.83. So this 0.0.83 is what my theoretical, right? I'm expecting I should get 0.83, but actually I'm getting 0.75. So substitute in the formula, the actual is 0. Actually is what? 0.75. This is actual, and theoretically you should get 0.83. So into 100. Simple maths we can do. 0.75 is what it is. 0 0.75 upon 0.83, right? This is 0.90 into 100. It's a 90.36, and we can see there should be some option. Yeah, it's option. Then option number D. So option number D is it's a 90%, right? So in this way, how to solve? You should know the formula and all. Now last MCQ of this 2.1 chapter, which is completely based upon the atom economy. Okay, so basically, what is the atom economy? So atom economy generally it is a measure of green chemistry. So green chemistry, what we expect? Always remember, in green chemistry, our priority is what should be a less product. So that is the main purpose of the green chemistry. So according to the formula, the atom economy is equal to the desired product upon the total molecular mass of the reactant into 100. Okay, so here we can see here, this is our reactant. Okay, this is our reactant, so this should come on denominator. Your desired product is what? Synthesis of methanol. So methanol should come on numerator. So where you can see in option, all three options, methanol is on the numerator. So okay, denominator we can see, we have methanol, we have this formaldehyde they also written, so this option gone. We want only reactant on denominator, right? Second thing they have given, this is methanol and this is reactant, so this option is 100% correct. This first one is gone. Third option, now there is a confusion and most of the students will not mark the third option and they will skip that. But you need to read the questions carefully. What they have given, the experimental yield is 100%. Now when the experimental yield is 100%, this water is also part of your reaction, and this is, so this can also form the reactant. So this should also come. So this methanol, sorry, yeah, this methanol should come here, so it should get cancelled. So this is 100%, it means this should get cancelled. Okay, so option here 2 and 3, so here C option is correct. Okay, okay, thank you. I hope you have understood. Thank you.